In this problem, we're told the transfer function for a network is h of s is s plus 10 over s squared plus 4s plus 8. Determine the pole zero plot of h of s, the type of damping exhibited by the network, and unit step response for this network. So to do the pole zero plot, first, if we look, zeros are associated with the numerator. So our numerator is s plus 10. If we look at where that's 0, we have a 0 at s equal minus 10. And then for the poles, those are the roots of the denominator. And we need to use the quadratic formula. So we have minus 4 plus or minus the square root of, we have 4 squared minus 4ac. So we have 4 times 1 times 8 over 2. So we have minus 4 plus or minus the square root of minus 16 over 2, which is minus 4 plus or minus j4 over 2. So the roots are minus 2 plus or minus j2. So we have one root at minus 2 plus j2 and the other root at minus 2 minus j2. Okay, so here are the zeros. I have two poles. So now if we want to construct the pole zero plot, okay, we have a 0 at minus 10. Okay, so out here at minus 10, there's our 0. Now our two poles are at minus 2 plus j2 and minus 2 minus j2. So out here at minus 2, here's plus j2, here's minus j2. So there's our two poles. So two poles, minus 2 plus j2, minus 2 minus j2. We have a 0 at minus 10. Now if we look at the type of damping, since we have complex conjugate poles, then that means we have an underdamped network. Okay, so the type of damping, we have an underdamped network. Now, our last task is to find the step response. Okay, so our output is going to be h of s times 1 over s. We're looking for the step response. So we have s plus 10 over s times s squared plus 4s plus 8. And we know that's s plus 10. Then we have s plus 2 minus j2, s plus 2 plus j2. And our partial fraction expansion then, k1 over s, k2 over s plus 2 minus j2, and then k2 conjugate over s plus 2 plus j2. So first, let's find k1. So we're going to multiply through by s and let s equal 0. So k1 is s plus 10 over s squared plus 4s plus 8. Evaluate s equals 0. Well, that's 10 over 8, or 1.25. Okay, now, for k2, we're going to multiply through by s plus 2 minus j2 and let s equal minus 2 plus j2. So then k2, s plus 10 over s times s plus 2 plus j2. Evaluate s equal minus 2 plus j2. That turns out to be 0.73 at an angle of minus 211 degrees. Okay, so now we're ready to do our inverse transform. So then the step response x of t then is 10/8 or 1.25. Okay, now we have 2 times the 0.73 we have e to the minus 2t cosine 2t minus 211 degrees u of t. So then x of t is 1.25 plus 1.46 e to the minus 2t cosine 2t minus 211 degrees u of t.